him, but he's supporting our Florida GeoGebra conferences, and he's wonderful speaker, a teacher, educator, innovator, and he will share with you his insight into statistics, starting statistics with stimulation. For 1 hour, you have a GeoGebra book link, and now I am turning off my mic and give floor to Stephen.
Good morning, everyone. Good morning. Hope you guys can hear me. Hope you guys can see my screen. Hopefully someone will speak up if you can't hear me or if you can't see my screen. So there is a link that was shared.
We can see you. We can hear you. We can see.
Yeah. So there was a link shared in the chat a while earlier. It's a tinyurl link. tinyurl.com/startsim. If you'd like access to this, there are some resources and links to videos and PDFs and websites. So you can have at that. So here are my thoughts for this morning. Again, I taught AP statistics and non-AP statistics for a number of years, and I'm not teaching it now, but it still has a place in my heart because I really do love the topic. And I think teaching statistics well, if you can teach statistics well, you can probably teach anything well. So my agenda for this morning is as follows. I'd like to share some resources and experience that changed my way of thinking about simulation in AP statistics and also in statistics in general. I have 3 short videos of appropriate, and if I could only spell correctly, that would be fantastic, but we'll fix those later. I have 3 short videos of some appropriate simulation scenarios for literally the first day of a statistics class. And then we'll have some time at the end to build a simple simulation that could be modified for other simulations. And my history with it, and I understand that causation and correlation are not the same thing. However, the years in AP statistics that I started the year day 1 with a simulation and getting kids working with the logic of inference, those were associated, it seemed like, with better AP statistics scores at the end. And I know AP stat scores aren't everything, but it was in my district at the time. So I'll click over here on the left-hand side. So here is one resource that kind of really changed how I wanted to approach statistics. This textbook, Introduction to Statistical Investigations, it is published by Wiley, and there is a link at the bottom that will take you to the publisher site. And there's actually a new edition. There's also an AP edition of this book. And man, this book starts right from the get-go, introducing you to simulation. So if you are a statistics teacher and are not like really, I'm not really certain about this, not sure what I should be doing, this book would be super helpful. So again, that's there. Go to the website and ask for a desktop copy of the textbook. They'll send you one. This next one is a PDF file. If I was ever traveling to a conference or had little time and I just want to kind of like rethink myself around statistics, this PDF, an introductory statistics course, a Ptolemaic curriculum, this always kind of struck a chord with me. You know, what we teach is largely the technical machinery of numerical approximations based on the normal distribution and its many subsidiary cogs. That little first sentence right there always kind of like made me go, man, I've got to do better. But essentially this article is all about, like, we have the technology. Why aren't we making better use of randomization-based inference and helping kids make that direct connection between data and the logic of inference? And it's that logic of inference, that way of thinking. I mean, that is the big idea in AP statistics, is this idea of inference. And in a typical stats course, it's not encountered until probably the second half of the year. But by engaging kids in simulation right from the get-go, they can start working with that big idea all year long. Another thing that that really also changed my approach to statistics was Serenbe outside of Atlanta. So if you're a Florida resident and attending this conference, maybe you've heard of Serenbe. It's kind of a weird little place, man. It's like it's a wellness community, but it kind of reminds me of that Tom Hanks movie where he's living in this little bubble and they're filming him. Is that the Truman Show? I think is what it was. Anyway, simulating Serenbe happened to 3 summers, and I would attend this summer, and there were some big names in statistics and AP statistics: Beth Chance, Paul Myers, Doug Tyson, Darren Starnes, Alan Rossman. All of these folks came and shared like their wisdom about simulation-based statistics. And these 3 summers really did really changed like everything, how I approach statistics from there on. This was the last one, and I believe that was in 2015. But that was an experience that really changed my idea. At the bottom of this page, there is a short PDF file, the history of simulation and AP statistics. So if you're an AP stats teacher, take a peek at that. Another thing that also really changed was this website, CauseWeb, a simulation-based statistical inference. Man, I love that. I love this website. Love it, love it, love it. And I'm having trouble with the links in GeoGebra, so I'm going to pop this puppy open into a new tab, and let's see if I switch that tab. Hopefully it will stay there. Introducing logic. There's a place on this website, like, what do I do on the first day of class? So I can see on the right-hand side, what do I do on the first day of class? And this is one of those things that you do on the first day of class. Introducing the logic of inference on day 1. And Soma Roy had a couple of really nice suggestions, and I would share these with you. The first one is to use an example based on a real study with an interesting research question. Now, the research questions in the 3 studies I'll share with you may or may not be interesting, but they are real studies. And these are things that kids can wrestle with first day of statistics. And I know you guys are past your first day of statistics, but Monday, if you have school, I know it's President's Day here in the US, or Tuesday is a whole new first day of statistics for you. Number 2, using a context that involves a simple 50-50 scenario. And so that is important because that's a coin flip, and kids can flip coins all day. So it gets them involved physically in the simulation right on day 1, lets them know that this is not their typical math class. And so I've got 3 scenarios that I can share with you about that. Avoid using formal terms. I did not necessarily always abide by that. I tried to kind of introduce these terms kind of like, just, oh, they would call this a null hypothesis, but we would, I mean, I wouldn't like hold them accountable for that then. And I didn't want to like drill that in there, but I would mention like, here's what we call these things in AP statistics, maybe not on day 1, but certainly at the end of that first week. And then we wanted to choose a sample size where it is small enough so that we can kind of model the simulation. So all of these are 50-50 scenarios that I'll share with you, and then we'll build this simulation at the end. And in a 50-50 scenario are just coin flips. And most of the sample sizes are very, very small. By small, less than 20. So kids could do 20 coin flips, and you could aggregate that data across your class and quickly create some dot plots. And where the technology comes in, it will allow you to create thousands and thousands of trials. And that is what we'll build at the end. So the first simulation, and oh, I shared my screen, but I don't know if I clicked on all of the boxes that meant I should have shared my sound. So this is the first one, Doris and Buzz. If you've never heard of Doris and Buzz, we'll play the first part. This video is a very long video. We'll play about the first minute and a half of this video. And I hope someone will yell at me if the sound is not clear. And if not, I will pause then and reshare my screen. So this is going to be a little bit clearer. So here is.
In this video, we give an introduction to chance models that is used in our Introduction to Statistical Investigations curriculum. This example is typically done during the first week of the semester and shows how we introduce students to inference. A famous study from the 1960s, Dr. Bastian explored whether two dolphins named Doris and Buzz could communicate abstract ideas. During a training period, Dr. Bastian placed buttons underwater on each end of a large pool, 2 for Doris and 2 for Buzz. Then he used an automobile headlight as his signal. When he turned the headlight on and let it shine steadily, he intended for the signal to mean, push the button on the right. When he let the signal blink, that meant, push the button on the left. Every time the dolphins pushed the correct button, Dr. Bastian gave them a reward of some fish. Eventually, Doris and Buzz caught on and earned a fish reward every time. Then Dr. Bastian made things a bit harder. Now Buzz had to push the button before Doris. If he didn't push his buttons in the correct order, no fish. After a bit more training, the dolphins caught on and again could earn a fish reward every time. The dolphins were now ready to participate in the real study to examine whether dolphins could communicate with each other. Dr. Bastian took away Buzz's headlight and placed a large canvas curtain in the middle of the pool. Dr. Bastian then turned on the headlight and let it flash. He watched to see what Doris would do. After looking at the light, Doris swam near the curtain and began to whistle loudly. Shortly after that, Buzz whistled back and pressed the button on the left. He got it correct, and so both got a fish. But this single attempt was not enough to convince Dr. Bastian that Doris had communicated with Buzz through her whistling. Dr. Bastian repeated the process several times, sometimes having the light blink and other times having it glow steadily. He kept track of how often Buzz pushed the correct button. In one phase of the study, Dr. Bastian had Buzz attempt to push the correct button a total of 16 times. In this sample of 16 attempts, Buzz pushed the correct button 15 out of 16 times.
So that's pretty impressive. And that seems, this scenario seems to agree with all of those points. I mean, the research question is, can dolphins communicate abstractly and provide directions on what button to press? Sample size is small. Well, it's not that the two dolphins, but there are 16 trials and they got something correct 15 out of 16 times. Kids could easily simulate this with a coin flip because it's a 50-50 proposition. I mean, the null hypothesis, even though we wouldn't use that, is that the dolphins are just guessing. And if they were just guessing, how likely would it be that they would get this correct 15 out of 16 times? So this is a Doris and Buzz. I'm surprised that many folks have not heard about this. But I heard about this in that textbook I shared earlier, Introduction to Statistical Investigations. And I've been using Doris and Buzz. That was always one of my first week things. Another one I used early is Hinders and Helpers. And so you may have seen this one. This is an interesting study from Yale University about how essentially babies kind of know between, what's right and what's wrong. And so here's a very short video about the helpers and hinders.
There's a domain of developmental psychology called theory of mind, which involves basically asking, how do we develop an understanding of other minds? How do we come to understand other people's thoughts, their relationship between their thoughts and their behaviors?
If you both want to do different things, what could you do?
How we reason about other minds in the world. Peekaboo! We began addressing some of these questions with infants.
In this study, parents bring their 6-month-olds into the lab.
At the other side of a long table is a hill stage. A red circle guy with googly eyes tries to climb the hill. He sort of goes up the hill and then falls back down. He always fails at it. Then a blue square character, also with googly eyes, comes from the bottom of the hill and bumps him up to the top of the hill so that he's successful. On different trials, the climber tries again to get to the top of the hill, and then a yellow triangle character comes down from the top and bumps him to the bottom of the hill, so prevents him from getting his goal. Babies see this a number of times until they get nice and bored with it. So we stop and basically do a choice measure. Moms are asked to close their eyes. An experimenter who did not see which character was which brings over the two characters to the babies and just sees which character the baby touches first.
Which one do you want?
We found that, impressively actually, almost 100% of babies preferred the more positive character.
What do you want?
So this is also, again, there's a lot more than just a simulation-based inference content here. There's this whole thing about experimental design. If you were listening, the mothers close their eyes, and there is an experimenter who presents like the square and the triangle who didn't know which was which. So sounds like a double-blind study. But that is something that could be shown over and over again. So we could do this in the first week of school. Are the babies guessing and just getting lucky? Or do babies actually know the difference between a helper and a hinderer? So another great thing that you can do on that on the first week of school, even on the very first day of school. Another one that fits well, and I know this has gone around. You may have seen this or heard this before. Smelling Parkinsons, and I know there's a nice Desmos activity goes along with this that is you'd probably see more often, but this is something that I've always used in my classes, and I've shared this with the kids, and we build simulations around this. So this is the last video, and then we'll talk about a couple other things, and we'll try to build a simulation. So this is the smelling Parkinsons.
Joy Milne first noted something odd about her husband's scent when he was 45. Shortly afterwards, he was diagnosed with Parkinson's. Now universities are testing if it's a coincidence or a newfound precaution. Here's Mike McCarthy from our British partner, Sky News.
When she was a teenager, Joy Milne started to realize that she had an acute sense of smell. But it was only when she noticed a change in her husband Les's odor that the incredible potential of her super sense became clear.
He was the anaesthetist. He was in a close situation in theatres, and he was working long hours. And I presumed, and the Parkinson's tiredness had kicked in then, but we didn't know that. And because he was so tired, I just thought, well, you're not showering enough. And I said so.
At first, Joy didn't know what the smell was until she recognised it in other people and said so at a meeting to discuss Parkinson's.
And I thought, this is it. This is the right moment. And I stood up and said, why are we not using the smell of Parkinson's? I can smell it in this room all around me.
Now at Manchester University, researchers supported by the charity Parkinsons UK are harnessing Joy's special skill. Once Joy's incredible ability had been recognised, she was given by the university a number of T-shirts. Now, half of them had been worn by Parkinson's sufferers, the other half by a control group. She got them all right, apart from one. That person went on to develop Parkinson's. Scientists believe that Parkinson's may cause a subtle change in the skin's natural oil.
So that was interesting. Was she got all of them right except for one, but that person, as it turns out, actually developed Parkinson's later. And so she seemed to be able to smell Parkinson's before typical tests would diagnose the disease. So three ideal simulation scenarios that you could use first day, first week, throughout the year, because there's also this idea of, experimental design and probably all three of these scenarios. These are perfect, small, short little scenarios to get kids talking about statistics. So what I would like to do is, how could we use GeoGebra to build this? And before I do that, though, I'll show you, I do have other statistics simulations. I've not done much with this over the last couple of years, unfortunately. But this exists, and I probably should have shared a link to this as well. What I've done is I went through a bunch of old AP statistics questions, and if they lent themselves to simulations, I built simulations around them. So there's one from 2012, the number 5 question, or 2015, number 2. And so those things exist. And if you just search for statistics simulations in GeoGebra, you'll find those things. So those are the 3 scenarios. So let's take the rest of our time. Let's see if we can build one of those things. Let's build a simple simulation. And I'm going to use the online version. Those of you who know me or know of me know that I like to use like the downloadable version, but I updated my Mac a while back and it's not working well. So that's okay. I've gotten really good with this and my students are using this as well. So when I'm on the website, I prefer to use GeoGebra Classic. So that's down here in the middle column. That's just my preference, kind of what I grew up on when using GeoGebra. So this is what I prefer. So all of these simulations, even thinking back to that, like the 4 points that you should do to like on day 1, all 3 of those scenarios involved a 50-50 chance. In other words, they were either guessing or they weren't. I mean, that my null hypothesis would be is that someone is guessing. I'm guessing that the shirt was worn by a Parkinson's patient. I'm guessing that this was a helper or hinderer. The dolphins were guessing. And so we could use H and T, but I think it's probably easier to use 0s and 1s. And so I'm going to call this variable a coin, and because most likely the kids in the class would be flipping a coin. And so I just want this coin. It's either going to be a 0 or a 1. It doesn't matter which one is heads or tails. I'd probably just choose 1 to be heads, but you don't have to be. And so I want my coin to be a random integer or a random integer between 2 values. And so in GeoGebra, I've got my random between. I know these things pop up as like helper text. I typically like to kind of type past it. I use it as a reference, but usually I don't click on those things. So random between, and I just want to have a random integer that's either 0 or 1. And then I'll press return. Now, so I've got this random kind of a coin flipper that'll be 0 or 1. But the problem is there's not a good way to flip the coin, so to speak. Like, how can I re-randomize my coin every time? And so in order to do this, we will need to create a button. And then we'll do some other things with this button in a little bit. But we're going to have to create a button that will flip this coin for us and will re-randomize everything that's in our simulation. And so the button tool is second. It's where the slider button is on the far right side of my toolbar. And so if I click on that slider button, 2/3 of the way down is the button. And so I'm going to turn on this tool. And then I'm just going to click over here, and it doesn't matter, in an empty space somewhere. And so I'll click on this, and then this box comes up, this dialog box. The caption is the title that's going to appear on the button. And so this is going to be flip the coin. That's what's going to appear on the button. And then the magic happens in the GeoGebra script itself. So in the GeoGebra script, I'm gonna click down into that GeoGebra script box. And then the command to re-randomize everything in my dog is like nudging my elbow as I type. So this could be troublesome. So it is update construction followed by empty parentheses. So that update construction, when I click on the button, that button will re-randomize the coin flip. and we're going to come back in a little bit. We'll add a little bit more to this script, maybe just one more line to this script to add some functionality. But for right now, I'm going to click OK. And then I need to see if I can wind myself out of this. Since I've zoomed in, let me try this. I'll reset my screen. There you go. Now, before I do anything else, you'll notice in my toolbar at the top, that button is still highlighted, which means that button is still active. So as I tell my kids, when you're done with a tool, put your tools away. And so I'll go over here and click on the arrow. You could also press escape on your keyboard. That will put that tool away. What would happen is if you clicked somewhere on your screen, it would think you're wanting to make another button. So let's test our button. Now that we put that tool away, if I flip the coin, there we go. I've got zeros and ones that are randomly kind of popping up. So my coin is kind of flipping. That's pretty good. Now, what I would like to do is I am thinking of the dolphin scenario. So the dolphins, if you recall, there were 16 trials. And so I would like to do 16 coin flips and kind of get them all together in one place or in one list in GeoGebra. And then we'll take a gander at those 16 coin flips. And so what I can do, and this is a super powerful tool. I love the sequence command in GeoGebra. So I'm just going to I'm going to type in the word sequence, and I'm not going to look at the help because I know what I want to do, but the sequence, then I'm going to put a parenthesis. And what I want to do is I want to just take my coin that I defined above, but I want 16 coins. So I would like to do this 16 times. And so I go, after the coin, I'm going to place a comma. And then the command works with like an index variable or a dummy variable. I'm just going to call that U. And I want U to go from 1 to 16. So in many ways, this is kind of like an if command that you might see in JavaScript or maybe in Java, or it's kind of like the for I in range command that you might see in Python. So the coin is going to re-randomize 16 times. So there are 16 elements of this. Listen, I'm going to press return, and that list's name is L1. So I need to remember that. And then when I flip on the coin, all of those numbers change. Now, in the dolphin experiment, it was there were 16 trials, and the dolphins got the correct button 15 of the 16 times. So what I would like to do is I would like to just add up, and let's say 1 is a correct guess and 0 is an incorrect guess. I just want to add up all of my ones. And so that is a sum command. And so what I'll do is I'm just going to go the sum of L1. And if I'd like to give this a more of a descriptive name, I can. So I'm just going to call this correct equals. And so when I press return, now I can kind of take a look at this, and ooh, there's 12. So that's 12 correct guesses out of 16. And I'm doing this. My students have watched the video. My students have simulated this physically with coins. My students have aggregated their data in some sort of a dot plot with like little sticky circles that you'll get from arts and craft stores. So they've created these dot plots. They're familiar with the dot plot now in the very first week of school, very first day of school, and they've seen the video. So this is now like a technological application of coin flipping. So what I'm wanting them to do is understand, what does that 12 mean? And that 12 stands for 12 correct guesses out of 16. And I flip again, and now it's 7 correct guesses. And I just want to keep flipping this coin until I come across 15. And I wonder if will I ever come across 15? I mean, if I never come across 15, then how the heck did the dolphins do that? I mean, if I never come across 15 correct coin flips just by chance alone, that means maybe the dolphins weren't guessing and that maybe the dolphins really were communicating with each other. And that's the whole logic of inference right there. On day one, first week of school, I don't need to get bogged down in the details of hypothesis testing, alternate hypotheses, z-scores, standard deviations. It's the logic of hypothesis testing. If the dolphins really were guessing, I would expect them to get it correct maybe 8, 9, or 10 times, maybe 11 times, maybe 7. But 15 times, I've never gotten to 15 yet. Never gotten to 15 yet. So if a 15 wouldn't happen by chance, then I've got to believe that the dolphins were able to communicate. So here's what I'd like to do next. I'd like to model. I don't want to keep clicking this button. But what I would like to do is when I click this button, I would love to take these correct numbers, the 7 that shows up. I would like to take that number and place it into another list. Like I want to keep all of those numbers together. So I'm going to make just an empty list and I'm going to call it trials because I would call it trials if I could spell it correctly. So my trials is going to be an empty list to start with. And so what I would like to do is every time I click on this button, I will re-randomize my flips. I will get a new correct sum, and then I can place that number into this empty list that is trials. So what I need to do is I need to edit my button. And so to edit my button, I'm going to right click on it, a 2-finger click on a Mac, right click on a Windows. And in this sub menu that shows up, in the sub menu, I'm going to go down to the settings command. And in the web version, it opens up on the right-hand side. So I'm going to shrink this menu on the left down, or this window just a tad. And I'm going to kind of expand that a little bit so we can see. And then there are some tabs at the top of my window. I've got basic text and so on. And I want to go to the far right where it says scripting. So the scripting tab is actually a kind of what happened when I originally filled out that little dialog box for my button, is I had typed in an update construction. And so what I can do is I want to put in a new command right underneath that. And so that new command is I want to set the value of the trials set. And what I want to do is every time I click on the button, I want to append, which means kind of add to the end, to the trials button. I want to add the sum. If I forget what I called that. I need to go back and look at that again. Let me see if I can zoom out of this and see what it was. Oh, correct, not sum, it's correct. So I want to take that correct number and stick it at the end. So this is nice. This automatically saves for me, and this is going to happen every time I click on the button. So every time I click on the button, I'm going to flip my coins. I'm going to get 16 new coins in my trials, and then I'm going to take that correct number, stick it in the end of the list. So I think everything's okay. Trials is okay. Correct is okay. I'm going to close this window out, and oh, I don't know what's going to happen. Let's click it and see. Yes, so what I've done is I've taken that last number, stuck it in there. So there it is. I flip it again. There goes 11. And so now I've got a list of coins. I've got a list of sums. And so what I could do next is I could make a dot plot of these sums. So if there was a command for dot plot, it might start with the word dot. And sure enough, there is dot plot. And I'm just gonna type in trials. That is the data I want to make a dot plot of. And you can see the dots on the right side of my screen, they show up. And I'm going to move my screen over to the right, and I'm just going to right click on the one of the dots, and I'm going to hide the label so we don't see the label. So I can flip this coin every time. And every time I flip this coin, I'm adding something to this. I am adding a trial of 16 flips to my trials list. And each dot, so this is kind of an important point because my students have done this already by hand. Each dot represents the number of correct guesses by the Dolphins out of 16 trials. So this dot right here, well, not that, not all the dots. This dot above the 6 represents 6 correct button pushes out of 16. And what I'm looking for is how often does a 15 or even a 16, 15 or greater, how often would that ever show up? And I'm just keep flipping my coins and I don't see any yet. Now, I've pressed that button a bunch of times. I would really like to know how many times I pressed the button. So I'd really like to know is how many numbers are in the trials list right up here. And so there is a command, that command is the length command. So if I went length followed by a parenthesis and then trials, my trials, that's this number here, that is 34. And what I'm going to do is I'm going to drag this. Let's see if this works. I'm going to grab that there, click and drag it. Will it go over there? Sometimes it does, sometimes it doesn't. Just depends what time of day it is. Sometimes I can drag that number right over there into the graphing area, but it's not playing nicely with me, so that's okay. I can still see it there. There are 34, and now there are 35. So what I would love to keep pressing this button until I had like maybe 100 flips or 200 flips, but man, that would really go slowly. So let's make another button that when I click on it, will do 10 flips at a time. And what we're going to do is we are going to actually reference this flip the coin button here. And so this button, when I right click on it, this button's name is button 1, lowercase b, followed by a 1 with no space. So I'm actually going to refer to button 1, and I'm going to execute. I'm going to run that button 1's script from another button, and it will happen 10 times. So this is a cool little trick. I really do like this. So I'm going to create a new button. So I'm going to go up there to my tools. I'm going to go click on the button. And I'm going to click over here in a white space somewhere. And let me zoom in a little bit so you can see this, and hopefully I can get unzoomed. We'll see what happens. And so I'm going to call this 10 flips. So this is going to do 10 flips at a time. And so there's a little known command in GeoGebra that is the repeat command. And what I want to do is I want to repeat the script that is in that other button 1. So I want to repeat that 10 times. So I'm going to repeat, and then I'm going to put in 2 parentheses because it takes 2 parentheses, and I'll put some spaces in there. I'm going to repeat this 10 times. And the thing I'm going to repeat requires that I use the execute command followed by 2 parentheses. And then what the execute command does is the execute command takes a list of text commands. So what I'm going to do is I'm going to put in curly braces inside this. There's my curly braces. So that's going to be a list. And then I'm going to put a pair of quotes in there because I want my command to go inside those quotes because it needs to take a list of strings or text commands. And so the command to make that other button run is called run click script. And in parentheses, the thing I want to run is the click script in button 1. So let's pause for a second and take a gander at this. I'm going to repeat this 10 times. I could change the 10 to a 100 and do it 100 times, but be aware, if you do it 100 times, there's going to be a little bit of a lag because it's got to do something 100 times. So I think if you did it 10 times, it might go a little bit quicker. What it's going to repeat 10 times, it's going to repeat this execute command. My execute command is actually going to run the click script that is in button number 1. So I'm kind of nervous. Let's see if this will work. Let's see if this will work. No idea, kids. No idea. I'm going to click OK. Let's see where it shows up. There it is. Now, if this button is going to work correctly, what I should see is 10 more dots appear in my dot plot. I should also see this 35 over here on the left-hand side. I should see that puppy go up to 45 if the button's working correct. If the button's not working correct, it's going to shout at me with an error message. So let's see what happens. I'm going to click. Oh, I also better make sure that I put I wonder if my tool is put away. Oh, see, I didn't put my tool away. I was going to click on that 10 flips button, and you know what would have happened? I would have created another button. So I'll click on move, and now let's go down here. Will 10 flips work? It did work. Notice the 45 went up there, went to 35, went to 45, and I've got more dots that appeared up here on my screen. Let's click it again. 55, and you'll notice I still have not run across a 15 or a 16 yet. And I've got 55 trials. So in a classroom, you may only have 15 or 20 kids in a class. And so you're aggregating your data over 15 or 20 kids. And going back to that one PDF article, this is what technology does. I can now do hundreds or thousands of trials quickly. So I can keep clicking this button, and I could quickly get above 100 trials. And I still haven't even gotten a 14 correct guesses yet. So this is the power. This is the power of the simulation. This is the power of simulation. There's a 14. Will I ever get a 15? Let's go to 200 and see what happens. So I'm at 205 trials. Each dot represents the number of correct guesses out of 16 attempts. And out of simulations, assuming that they were just guessing, I saw 14 occur one time. 14 correct guesses occur once out of 205 guesses. So if they really were guessing, there's no way there's no way they would get 15 guesses correct. There's no way. So the only plausible explanation is that the dolphins were communicating with each other. And that's the logic of inference. That is what inference is all about. Let's see, a couple other tricks before I go. I do like this new trick. I would love to have like a kind of like a tally of all of my flips. I would love to kind of organize that a little bit better, because I really would like to know is like how many 8s there were. How many times did 8 appear in my data set? And so there is a pretty cool command. Let's see if I can make this zoom. Oh, there, that's better. So it is a command. Let's see. I think it is called frequency table. I'm taking a risk here typing in the word frequency. You know that, don't you? Frequency table. And I just want to make a frequency table out of my trials list. So there's my trials list, and here's my frequency table. I'll drag that puppy over here. So I bet you didn't know that existed. So that gives you a frequency table. So I know right now that 8 occurred 45 times. 8 occurred 45 times and 14 occurred once. That's the frequency table command. That's pretty nice. Here's what I would also like to do. I would love to have a button that would allow me to kind of start over or reset this. In other words, what I would really like to do is I would like to take the trials list up here in this line. I'd like to take that trials list and I would like to empty it so I could start again. So if I took another, I'm going to have buttons all over here, just like willy-nilly, man. So I'm going to activate my button. I'll click out here in a white space somewhere. And then I'm going to call this I'm just going to call this reset. And let me zoom in a little bit so you can see this. I don't want to zoom in too far. I'll never be able to zoom back out. And essentially what I want to do is I want to take my trials list. I want to set the value of my trials list to be the empty list. So every time I click on this, it will go back to empty. I could probably get by just going trials equals the empty list, but I'm just used to doing set value. So that seems to work okay. Let me see if I can zoom out of this puppy again. I did. I'll press OK. I'm going to put my tool away because my button tool is still active. I'm putting my tool away. So I'm going to click over here on the left-hand side to where the move button is. And I'm going to click reset. And so that kind of reset it. Now let's do 10 flips. There are 10 flips. Let's get to it. Let's get to 100. Will we ever get 15? Still have not gotten a 15. There's 70. I got 3 more flips. 1 more set of 10 flips. And there we go, man. 100, still haven't seen 15. So I'm going to assume those dolphins knew what they were doing and were able to talk to each other. So let's see, kids, if any, let me see, can I find my chat window? Or is there a Q&A window? I don't know. Kasha or whoever, I'd be curious to know if there are any questions, something I can do for you guys or around this simulation, because I've probably exhausted about everything I think I could do with this simulation. There might be some other things I could do, but
wonderful, wonderful, Stephen. We love it. Yes. Louder.
If there's any questions, shout them out. If not, yeah, you guys can get
everybody was clapping. There was like everybody was clapping. Okay, so there was like 16. I don't know, 24. So are there any questions here in this room? Wait. Maybe you can come. Oh, you don't want? Oh, I don't know how to do lapel. Come.
How can I? Oh, so I see some Q&A.
Wait. You want to see us?
So Steve, can you hear me?
Yes.
Hi, Steve. So we have a question from the audience. Once you create the simulation, right?
Yes.
Is there a way to save that before you close out of it so that you can, have the programming, be able to share that with your students, maybe reset and play it again with them?
Yes. So you can see my screen up. I assume you can see my screen.
Yes, sir. Yep.
In the of course, I would really like to kind of clean it up a little bit before I do this. So in the upper right-hand corner of my screen, there's a magnifying glass, and just to the right of the magnifying glass is those 3 horizontal lines. Sometimes they're called a pancake stack or maybe a hamburger. If you click on that pancake stack, the first menu is the file menu. And I just go down here to save. So I just go to save. And then it's going to prompt me to name it. So I'll just call this FLGGB 2023. So I remember what it is. And right now it's set to private. I'm going to change that to shared. And then I'll click on save. And then what will happen is this will save to your profile in GeoGebra. So if I go back here to GeoGebra, and I love Zoom, there's windows everywhere you don't want windows to be. In GeoGebra on the left-hand side, if I go to my profile.
I just want to point out that you should have a profile open because you can do it anonymously.
Right.
But it's good when you create something to be logged in your profile for GeoGebra.
Right, Kasha. So Steve is talking about, we have some learners here in front of us that are new. So when you log into GeoGebra, you do want to create an account so that you have a profile saved, because in order to save some content, GeoGebra needs to know where to save it. So you would log into your profile, right? And you saw that it was saved in Steve's profile under his what's it called again, the resources?
That's just in my profile.
Yeah,
So I click
yep.
on the profile on the left-hand side. And this is like my library of things, which is not very organized.
That's okay.
But at the very upper left corner, that's the most recent thing that I've done is this is what it looks like within GeoGebra. You'll notice that the tools don't show up at the top, but all of the buttons that are here, all the buttons work. I can reset and I can try again. So I can flip one coin at a time, or I can flip 10 flips. And there are other things that you can do on the left-hand side, but maybe this is something that you guys can talk about when you have some free time in between sessions later on this afternoon, is how can I kind of clean up an app that I've created on the, like in my profile.
Yes, and later on in session, Steve, also what they'll do is they'll notice the assign button appeared. So if they want to assign that resource now to their class can use that resource that you created. You can share it to your Google Classroom and all that type of stuff.
There's some questions, Steve,
I see a couple in the Q&A. I'm not sure about can we reverse the process? I'm not sure about that question, so if we can clarify, but could I share the scripts for the buttons? So
Steve, your video is being recorded, Steve.
And there you go. You're good then.
Right.
You'll be able
everything, right.
Yep.
Everything that you're doing, participants will be able to go to the GeoGebra, Florida GeoGebra.
No, in our conference page, when it will be linked to YouTube, GeoGebra.
Thank you. Thank you. Yep.
One more thing, if I may point out, is the scripts Stephen was working on. There is a manual for GeoGebra, and you can check out the scripts. But this is like a little bit higher level. You really have to do a lot of GeoGebra to do that. So it's good to reuse. So one of the beautiful things of GeoGebra and software like that this is shareable. So whatever Steve created and a lot of other creators, they can hide it. They can save it as private. But very often there are teachers like you or educators, and they share. And you can download to your computer or to your profile, they work, and you can modify. So you can modify the buttons, you can, add something, or you can start from the scratch. So there are many levels of the work with GeoGebra. Okay, so this is a basic level when you use somebody else's work, or you use it as a calculator, or you try to create, first maybe recreate, modify some other else's job, and then to create your own. Just a small thing. We have here MST program at FAU, Master for Teachers in Mathematics, and we use GeoGebra as a tool to teach mathematics on graduate level, and also to learn how to use it for your own work and how to create books, how to create worksheets, how to work it out with here. So we have a couple of people who finish our program or are in our program. And it is so wonderful if you have time to put aside and learn what Steve is such a wonderful, knowledgeable person and showing at backstage. But this is, he's not trained in programming. Yes, Stephen, you are not trained in programming. Yes, you are just regular teacher who learn by yourself. Are you a regular teacher?
I've been using GeoGebra for probably 15 or 16 years now, and there are certain commands that I just use over and over again, and I know where to look if I want to find something else. But all you have to do, if you have questions, just reach out. My contact information, I'm sure, will be shared at some time. Hit me up on Twitter or just shoot me an email. More than happy to help you guys out.
Absolutely. Thank you so much, Stephen. Thank you so much.
A little bit later.
Let's give a round of applause. Thank you so much.
Thanks, everyone. Have a good morning.
See you next session. Your next session is only online. So it's during our lunch time at 12, but it will be broadcasted here and recorded if you want to see it later.
That'd be cool.
Okay, thank you so
See
much.
you in a bit.
Okay, wonderful. So right now, what we will be doing, we will have a 5 minutes break, and we will have a next session. It's 9:55. We have to be precise, Rob, with this online thing. Oh,